In this video, we're going to try to produce a more concrete definition of what we mean when we talk about a process as far as an operating system is concerned. And we're also going to define what we mean by a thread and how they differ. There's really not a lot you need to recall for this, but just keep in mind the concepts that we talked about in the last two videos about the basics of processes. Think terms like instruction cycle, program counter, and instruction and data memory should make sense to you at this point. So before we launch into our definition, we can think of a few things that might describe a process as we think about it. We can consider the most obvious definition. It's just a program that is being executed. We can think of it as an instance of a particular program running on a computer. The entity that we can assign to and execute on a processor, so whatever we can bundle up and send to a CPU to be executed. And we can finally really clarify down at what we sort of mean. The unit of activity characterized by the execution of a sequence of instructions. So we have a series of instructions that are going to get executed on the CPU. Some information about its current state, and I use the word state there very loosely just to describe the current situation and context of a process. And the associated set of system resources that we need for that block of instructions to work properly. So things like any I/O devices that might be needed, any memory that might be needed, kernel information, stuff like that. Now, whilst some of those things may be somewhat irrelevant depending on the situation, we do always have two really key elements for anything that we would consider to be a process. We have the code that we're going to run, so the set of instructions that are going to be run, and then we have the data that those instructions are going to be run on. And we really need those two things, otherwise we're not really talking about anything interesting. Now, when the processor is about to execute this bundle of code and data, so the code on the data, then we refer to what we're about to execute, the entity that we're about to execute, as a process. The other thing that we discussed about was the sort of the context information of a process. So we've said that the core element was instructions and data, but there was also a bunch of extra information that we could consider to be part of the process, in a sense, that was required for executing it. So when an operating system is running a process, it might like to keep track of a bunch of different information related to it. So there'll obviously be something simple like an identifier for keeping track of which process is which. There'll be state information, so this will make more sense later when we talk about interrupting processes and processes have different state. Some of you may already be familiar with the concept of priority when it comes to processes. Some processes might have more priority over others for when we decide which process to execute next. Obviously, you should be aware of what the program counter is. A process will also have any associated memory data information related to it. Context data, so the context that the process is running in, is it in kernel mode, other useful context information. We might have I/O status information, so there might be a list of I/O devices allocated to the process and the status that they are in. And then our counting information, so the operating system might be keeping track of how much CPU the process has used, are there any time limits, are there particular execution IDs, things like that. Now, don't be particularly concerned if a lot of the things that we've mentioned here don't make much sense, because this video is a bit of a chicken and an egg problem, because we're going to introduce what we mean by a process, and then later we're actually going to introduce in more detail in the lectures what each of these things are. But just keep in mind in general that there will be a lot of other data other than just the instructions and the data that those instructions are running on that the operating system will need to keep in mind for what it considers to be that process, everything that it needs to keep in order to be able to execute and manage that process. So now that we've got this idea of the process and any related control information, which was what we were just talking about on the last slide, we can now talk about a very common element of operating systems, the process control block. So this is a block of data that contains all of the information necessary for the operating system to control the process. So with this block of information, and you can see here, it's essentially a list of things just like what we mentioned on the previous slide, but it contains all of the key elements for the process. It makes it possible for us to interrupt the process and resume it by saving all of this information in the process control block somewhere else, and then loading the information for another process process's process control block into memory. We're able to then run a different process. This thing is created and managed by the operating system. It's not something that the process itself cares about, and it's a key tool for us to be able to have an operating system which can handle multiple processes at the same time. Now, what exactly is in that and how we handle it and manage it is something that we'll expand on in the lectures. So far we've talked about what a process is from a bunch of different angles. We've talked about what the minimum sort of thing we need for what we consider to be a process, i.e. instructions and data. We've talked about a process and its associated context in terms of how an operating system controls that, and we've discussed and introduced the idea of the process control block. But we can also think about a process from sort of two important but different angles. We can consider a process in terms of its resource ownership, so what memory it has been allocated, since it will need memory to run, other resources it's been allocated, such as I/O devices that it might have exclusive access to. There might be other hardware resources that a process has. And we can consider, as far as the operating system is concerned, one aspect of a process is what resources belong to that process. And we'll go over this sort of concept in a lot more detail throughout the remaining lectures. Another thing we can consider, another angle we can consider a process from, is the actual executing of the process. So how is its current running state, whereabouts in its instruction memory are we up to, so what's the current process counter, is it currently running, or have we got it suspended in order to let another process run? And maybe there are more ways we can think about that other than just suspended and running, but we'll talk about that in more detail later. But one thing to keep in mind is this idea that we can have resource ownership, and then we can also have execution of instructions and scheduling of execution as almost two distinct but core components of what a process is to an operating system. So when we think of these two angles from which to look at a process, resource ownership and scheduling and execution, we end up with two terms that we will commonly use throughout this course to refer to each of those situations. So when we talk about the unit of resource information, so what single thing do we have that may or may not have resources allocated to it, we will typically refer to that as a process or task, depending. And we will usually use the word process, but task may crop up, and it is also a very common word for within the operating system nomenclature, which refers to the same concept of resource ownership. When we're talking about dispatching a process for execution, so sending something off to execute and then to run, we will often refer to that unit, so the unit of actually executing and dispatching, as a thread, or something that we won't use very often, but is sometimes said, is called lightweight process. But basically we've got this idea of resource ownership, in which we will use the word process or task to refer to that, and then we've also got the idea of dispatching, so how the execution of actual instructions, and we will often use thread to refer to that unit. Here we can also introduce the term multi-threading, which is the ability of an operating system to support a single process having multiple concurrent paths of execution. So we might have one process with all its resources having several threads running, not necessarily in parallel, but at the same time, whilst having access to that shared bundle of resources. So the ability of an operating system to do that is what we refer to as multi-threading. In this slide, we're going to give a brief overview of the kinds of multi-process and multi-thread handling that an operating system might support. So this is independent of what the actual hardware itself can support. This is what an operating system might be able to handle, so at the software level. So we have the most basic, which is having a single process that can only execute one thread at a time. So each process can only have one path of execution, so we would say that this is not a multi-threading environment. It's also not a multi-processing environment because we can only handle one process happening concurrently. And so a very old example of an operating system that had this style would be MS-DOS. We can also think about something that can still only handle one process at a time, so one unit of resource allocation at a time, but that within that process there might be multiple threads. So we would say this is a multi-threading but not a multi-processing environment. An example of that might be the Java runtime environment. We can also consider from a different angle the idea that we might have multiple processes, so multiple units of resource allocation, so individual processes each with their own resources all being executed concurrently and swapped in and out, but where within each of those processes we can only run one thread of execution. So that would be a multi-processing but not a multi-threading environment. And some old versions of Unix had this style of I say multi-threading, but it's really not multi-threading. And then what we have really here in the final case is multi-processing and multi-threading, of which any reasonable operating system is going to support multi-processing and multi-threading these days, especially considering the trend in processing hardware design, where we're not increasing clock speeds so much, but we're increasing more and more cores on one chip, and the ability to handle multiple threads through the same data path with hyper-threading, things like that. So this is pretty much the standard now. We can have multiple units of resource allocation, so multiple processes, and then each of those processes can have multiple concurrent paths of execution or threads. So Windows, Solaris, modern Linux, Unix, etc. are all going to have multiprocessing and multi-threading. Now obviously, if the actual hardware that you're running this operating system on can only handle single instructions at a time, these traces aren't actually going to happen in parallel in time. They're actually going to refer to traces that are getting interleaved and swapped in and out. So the takeaway for this video is what a process is as far as an operating system is concerned, what comprises the elements of the state of a process as far as an operating system is concerned, what the process control block is, and threads as distinct from processes, and the methods of multi-threading and multiple process handling that an operating system might have.